Alright, so let's say you're given this diagram, and the question asks you, find the work done by the guy pushing the object. So we start off by identifying what is work. When an object undergoes a displacement of magnitude delta x along a straight line caused by a constant force F acting on that object, the work done is defined by this constant force and given by this equation here, where F is the constant force along the x direction, and delta x is the displacement due to this constant force. But what are the units? We know that force is given in newtons and displacement is given in meters, so if we just multiply those two values, it's Newton meters, which also is representative of this new unit called a joule. And this is the SI unit for work. So we can bring this back to our example. We apply our equation here. Notice that F is not going to be this 5 newtons. We need it along the direction of displacement. It's asking it to be F of x. So we have to use trig. Fx is going to be equal to 5 newtons cos 30, because if you remember, cos is equal to adjacent over hypotenuse, and F of x is adjacent to 30 degrees. We also know that delta x is 5 meters, so we plug those both in, do a simple multiplication, and then replace Newton meters by joules, and we get this for the final answer. This is going to be the work due to the constant force applied on the object in the direction delta x. If we look at our diagram here, the force applied by the person in the x-axis is 4.33 newtons, and then the work that we solved for because of this force was 21.65 joules. An important note here, only F of x contributed to work. F of x is given by F cos 30, so we can write a general equation for work equal to this below, where F is the magnitude of the force vector, delta x is the magnitude of displacement, and then theta is just the angle between the force vector and the displacement vector. It could also be written in the form of a dot product here, if we remember that when we take the dot product of two vectors, it's equal to their magnitudes times the angle between them, like seen in this expression here, so that's why that makes sense.